asked a while ago if I could make a video about BPA. Steph, my dear, your wish is my command. You all know BPA from the BPA-free stickers on drinking bottles. But what is the actual deal with it? Should we avoid it? And what about the alternatives? Join me for a game of chemical wack-a-mole. If you like these videos, don't forget to subscribe to my channel and click the bell button to never miss a video in the future. Alright, let's get into the science. What is BPA? Bisphenol A, or BPA in short, is produced by the synthesis of acetone, like the one that is sometimes in nail polish remover, with two equivalents of phenol by condensation reactions, so releasing water, catalyzed by a strong acid. You can then react BPA with another chemical called carbonyl chloride, also called phosgene, to form long polymer chains. These chains form a relatively durable plastic called polycarbonate, or PC in short. Around 70% of BPA's use is as comonomer in the production of polycarbonates. And that hard clear polymer is the most common plastic in our everyday life. What does that mean? It means that BPA is commonly found in things like DVDs, shatter-resistant glasses, the resin that lines cans of some foods, the thermal paper receipt you get in shops, and until very recently, bottles. For fizzy drinks, but also baby bottles. It is everywhere. So much that most people have detectable levels of BPA in their urine. But so far, this hasn't caused the collapse of civilization, although 2020 may have come close. Anyway, even though there is a whole lot of research on bisphenol A, it is not completely clear that it is completely safe. So if that's not completely clear, why do manufacturers opt for leaving it out then? And advertise it on their bottles and cans? The thing is this, those long polymer chains are chemically pretty inactive. The trouble comes when unreacted BPA sticks around in the plastic. If you now heat this up, for example by putting your leftover food container in the microwave, those leftover BPA molecules can become free, and this might be a problem. But why? BPA is an endocrine-disrupting chemical. If you watched my first cosmetics video, you already know about them from parabens. So to recap, it's a chemical that interferes with how natural hormones like estrogen, androgen or thyroid hormones work in the body. And because of that, researchers have looked extensively at health implications of BPA consumption. And indeed, numerous animal studies link BPA to implications like decreased fertility, impaired fetal development, obesity and cardiovascular diseases. So does this mean BPA is bad for us? Well, here's the problem. Similar to the studies we discussed for health implications of artificial sweeteners, animal studies of BPA can't just be translated into humans. Laboratory conditions where a certain dose of pure BPA is given to animals also don't really mimic accurately the way we interact with it in terms of dosage and exposure. Plus, not all those research results have been reproducible. So there's a lot of research studies out there that claim that BPA is bad, but not really a common conclusion on how or why. Right now, the TGA in Australia sets the safe limit of BPA exposure at 50 microgram per kilogram body weight per day, which is the same as the FDA in America sets its limit. The European Food Safety Authorization re-evaluated this limit in 2015 and lowered it to 4 microgram per kilogram body weight. Some scientists, however, argue that those limits are still too high. So why is that? The crux lies in the fact that bisphenol A is a hormone disruptor and might therefore act differently to other toxic or harmful substances. Usually the rule of thumb is more of the bad stuff means more bad news for our body. But chemicals that target the endocrine system have been known to break that rule. The little rebels. There are some studies that state a low dose of endocrine disrupting chemicals might be worse than a high dose. How can this be? They argue that if the body suddenly detects a high dose, it knows that something is not right and won't react to hormonal triggers like it usually would. So it seems, after all, that BPA is not that harmful for humans. although it might still be a good idea to not put it in baby bottles. Australia actually regulated this back in 2010. The real problem with all of this is that it leads to a game that I like to call chemical wack-a-mole, with manufacturers trying to avoid BPA, so knocking one chemical on the head, they have to replace it with another chemical. In the case of bisphenol A, it is now commonly replaced with bisphenol S, BPS, or bisphenol F, BPF. So surely these are then safer alternatives. Well, this review from 2015 showed that BPS and BPF have the same or similar chemical activity as BPA and also act as endocrine disruptors in humans. Some of this just didn't quite get as much media attention. So what do we do now? Stop worrying and using glass instead of plastic whenever we can. That's better for the environment anyway. Thank you so much, Steph, for asking, and I hope I answered your question. I'll see you all in my next video. Until then, stay sciencey. Do you have a question about specific chemicals you want me to look into? Leave it in the comments below for your moment of fame in one of my next videos.